In this video, we are going to talk about vertical and horizontal shrinking and stretching, or the distortion of the graph. Let's talk about vertical shrinking and stretching. Given y is equal to f of x, and we let a be a number that is positive, then if a is greater than 1, then the graph of y is equal to a times f of x. So here we're multiplying by the function f of x, the whole function, by a positive number a. So the graph of that function a times f of x is the graph of the parent function f of x that's being stretched vertically by a factor of a. And then if a is between 0 and 1, so it could be like 1/2, 1/4, and so on, then the graph of y is equal to a times f of x is the graph of f of x shrunk vertically by a factor of a. So let's try to picture this. Stretch vertically and shrunk vertically. What does it even look like? So imagine a rubber band. So let's say we have a rubber band. If we stretch it vertically, that means we are going to pull the rubber band in both directions, north and south. What's going to happen to the rubber band? The rubber band will become longer and skinnier as we are pulling it in both directions. We're pulling it in the vertical direction. And shrunk vertically. So now imagine that we are compressing the rubber band. So when you compress the rubber band, then it is going to be more flat. It's going to be wider instead of longer in the vertical direction. Now, when you transform your points, we are going to, in both cases, you are going to replace the point xy to the point, keep x the same, and just multiply all the y coordinates by the constant a. So let's try to graph 2x squared here. First, determining the parent function. The parent function would be the x squared function, where some critical points are 0, 0, 1, 1, and 2, 4. So with these points, let's write them down. We are going to transform them. The constant a here is 2, so we are supposed to keep all the x's the same. And with all the y coordinates, we are going to times it by 2. So that's 0 times 2 is 0, 1 times 2 is 2, and 4 times 2 is 8. So now, let's plot those points. 0, 0, 1, 2, and 2, 8. Because a parabola is symmetric along the y-axis, I can just reflect some points over on the other side of the y-axis here. So if this was the original function, or the parent function, if this was the parent function, which is the function x squared, then this right here is the graph of the function 2x squared. And as you can see, it looks skinnier. And imagine that it's stretching vertically. All right, let's try the next one. So we have h of x is equal to 1/2 x squared. Again, using the same points, we are going to transform these same points. But this time, we are going to multiply all the y coordinates by 1/2. So keep all the x's the same. 0 times 1/2 is 0, 1 times 1/2 is 1/2, and 4 times 1/2 gives you 2. Let's look at the parent function so we can compare it to the 1/2 times x squared function. So here is the x squared function. And to get the other function, we're going to plot the new points that we transform. So 0, 0, 1, 1/2. So that's going to be here, very tiny here. And then we have 2, 2. 2, 2 is going to be here. And reflect on the other side. We have negative 1/2 and negative 2, 2. And just connect these. We have this parabola. So looking at it in the vertical direction, as you can see that it has been compressed, so it's become wider on the sides. Next up, we have a horizontal stretching and shrinking. Given y is equal to f of x, where a is greater than 0, again, when a is greater than 1, then the graph of y is equal to f of a times x. This time you can see that x is the one that is being multiplied by a, not the whole function f anymore. So this is the graph of y is equal to f of x shrunk horizontally by a factor of 1 over a. And when a is between 0 and 1, so the graph of y is equal to f of a times x is the graph of y equals f of x stretched horizontally by a factor of 1 over a. So again, you're picturing the rubber band, but this time we're going to stretch it on both directions, left and right, instead of up and down. And same, compress it from the two sides, left and right. So let's try example 4. So I want you to compare example 3 and example 4. Notice how in example 3 we have 2 times x squared being f of x, which is the parent function. And then we multiply 2 by the whole function, the whole parent function f of x. So 2 times x squared, 2 times x squared. Now in example 4, however, we take x and multiply by 2 first. Like I said, a is being multiplied directly by x, and then you square the function. So when you transform points, here's what you're going to do. You will transform point xy to, you'll keep y the same, and for x, you are going to divide it by the constant a. So let's again use the same points that we've been using, 0, 0, 1, 1, and 2, 4. Let's transform those. We're going to keep all the y coordinates the same. And with the x coordinates, we're going to divide it by the constant a here is 2. So divide by 2. So that is going to be 0 divided by 2 is 0, 1 divided by 2 is 1/2, 2 divided by 2 is 1. Now we can plot the new points. So we have 0, 0, 1/2, 1. That's going to be here. And 1, 4. That's going to be here. And reflect it on the other side. And you have the parabola. Now, what is this case? Since a is 2, which is greater than 1, this is a case where the function shrunk horizontally. In other words, imagine you are compressing this graph from left to right. And as you can see, it looks skinnier because you're compressing it from both sides. All right, so next up we have h of x is equal to 1/2 x and then squared. So again, the parent function here is the x squared function, and we're transforming the same 3 points, 1, 1, and 2, 4. Again, we're keeping all the y values the same, and with the x values, remember we want to do x over a, x divided by a, and a here is 1/2. So we're taking x and divide everything by 1/2. So when you do x divide by 1/2, that is the same as x divide by 1/2, written it this way. So x can be written as x over 1. When you divide these two, you use a keep, change, flip method, which is keep the first fraction the same, change division to multiplication, and flip the fraction. So it turns out to be 2 times x. So x divided by 1/2 is the same as multiplying x by 2. So that's what we're going to do. So 0 times 2 is 0, 1 times 2 is 2, and 2 times 2 is 4. So our points are 0, 0, 2, 1, and 4, 4. So reflecting on this side, that's going to be -2, 1, and -4, 4. That's about there. As you notice that this graph is a lot wider than the graph that we just did for 2x and then squared. That is because this is a case where the graph is being stretched horizontally. So this one is the stretch case. Stretch horizontally, which means that you are pulling the graph in both directions, left and right. And so now it becomes wider.